Welcome to Study Loop.
At what angle should the axis of the two Polaroids be placed so as to reduce the intensity of the incident unpolarized light by an additional factor of 4, 10, and 100? So this question we have two polarizers. After the initial light passes the first one, its intensity is reduced in half. And we're asking how should we place the second one so that we reduce by another factor of 4, 10, and 100. So that can be done because we know that when an already polarized light passes through a second polarizer, its intensity will be reduced by a factor of cosine squared theta, where theta is the angle between the axes of the two polarizers. So if this one becomes 1/4 of the original intensity, what we can get is cosine squared theta equals 1/4, or theta equals arc cosine of square root 1/4, which is 1 second, so it gives us 60 degrees. This is case 1. Case 2, cosine squared theta equals 1/10. So theta equals arc cosine of square root 1/10. And that gives us an angle of roughly 72 degrees. In the third one, we have cosine squared theta equals 1/100. So theta equals 1 times square root of 1/100. So that gives us an angle of roughly 84 degrees. So the more we want the intensity to decrease, the more normal these two axes should be. They should be so when we eventually increase the angle between two axes from 60 to 84, and that cuts the intensity by a factor that goes from 4 to 100. And you can imagine if the angle is 90 degrees when these two Polaroids are completely perpendicular to each other, then no light will be able to pass, and we will reduce the light by a factor of infinity.